Hey, Algebra 2, welcome to the notes section of this skills kind of little thing that we're going to do, solving quadratic skills. We got three of them we're going to look at. The first one is the product property of square roots. When we're talking about quadratics, we're going to use a lot of squares and square roots and throw that kind of terminology around. So let's kind of see some ways we can make things work. Also, if it doesn't make sense right away, it's okay. We're going to keep practicing these skills as we move through the targets. Okay, so we'll just keep going here. We got the first one. The first one's the product property of square roots. Product, obviously, product is multiplication. So if we've got the square root of two numbers that are multiplied, so the square root of a times b, this could also be the square root of a times the square root of b. Also, big key in here, they have to be greater than or equal to 0. We do not want to use negative numbers for these, for this property part, okay? And let's see what this means, all right? If I take the square root of 12, what I'm looking for is the biggest, the largest perfect square number that I can take out. Or when I say take out, when I split it. In this case, I know that the square root of 12 could be broken down to the square root of 4 times 3, because 12 is just 4 times 3. What's nice about that? Well, we can use our product property. We can say, well, this is the same as the square root of 4 times the square root of 3. Interesting. Because what do we know about the square root of 4? Yeah, it is. It is. So this would be like 2 times the square root of 3. And that is how we would simplify that. Now you'll notice that I write my whole number before I write the one that's in the radical sign, right? Radical. It's before I write the one in the square root sign, in the root sign. So I write the 2, which is a whole number, times the square root of 3, right? That's just kind of a way that we write this, okay? Well, let's look at another example here. Example 2, we have the square root of 80. The square root of 80. Well, some of you may see right away that this could be like the square root of 16 times 5. And if you see that right away, fantastic, because what you're going to see is square root of 16 times the square root of 5, or 4 times the square root of 5, okay? And that's fantastic. That is what we're trying to get to. Let's say you don't see that right away. Let's say you don't see that right away, but you're like, oh, you know what? How about 4? Well, I could do 4 times 20. I'll do a different color for this one. I could make this the square root of 4 times 20. And I'm like, wait a second. I could also do, well, yeah, 20 in there. That's 4 times 5. I could also make this look like the square root of 4 times the square, oops, hold on. Square root of 4 times 5. And if I did that, I could say square root of 4 times the square root of 4 times the square root of 5. Well, we know the square root of 4 is 2. So this would be like 2 times 2 times the square root of 5. And we do know 2 times 2. We do know 2 times 2. We end up with 4 times the square root of 5. And you can see, no matter which way we went about it, we ended up with the same solution here. Okay, so here's your chance right now. Hit pause. Try what you can with the square root of 72. When you come back, we'll take a look at it. All right, now that you're back, let's go ahead and do this thing. Well, we got this 72. 72. I know I could divide it by 2. Let's see, what's 72 divided by 2? Hey, 36. That's interesting because I know something about 36. I know something about, we could make this the square root of 36 times 2. This could also be the square root of 36 times the square root of 2. And what is the square root of 36? Nailed it. Nailed it. 6 times the square root of 2. Again, if you don't see it right away, break it down. Keep breaking it down. Look to see if you can find the squares, some perfect square numbers. Remember, what are some perfect square numbers? How about 1? We're not going to use that a whole lot. We've got 4. That's a perfect square. We've got 9, 16, 25, 36, 49, 64. That's up to 8. We get to 9, we get to 81. We got 100. What's 11 squared? 121. 12 squared is 144. Remember, if you want to just write them down here, these are the squareds. Move this guy out of the way here. Meaning that the square root of the numbers on top gives you the number on bottom. If you want to get to square root of 13, the next one, so this would be 13 squared. Okay. Again, that's just a way to kind of think about that. Look for the largest square, the largest perfect square in your multiplying. Okay. Well, square roots don't just involve multiplication. We also have a little bit of division going on here. What happens when you have quotients or division? The quotient property of square roots. Let's say you have the square root of a fraction, the square root of a divided by b. Well, what can we do with that? Similar to the product property, it becomes the square root of a divided by the square root of b. Don't forget also, you can go from the right side back to the left too. We'll see examples of that later. Notice here the restrictions. A just has to be bigger than or equal to 0. It could still be 0. B has to be bigger than 0 because we can't have a negative right now in what we're trying to do. And it can't be 0 because you can't divide by 0. It's undefined. Okay. So let's see, what does this look like? Okay, we've got the square root of 4 divided by the square root of 9. So let's go ahead. Let's make this. We've got the square root of 4 divided by the square root of 9. Well, yeah, I mean, those are nice perfect squares, Mr. Brayman. Yeah, it's like I chose it that way. 2/3. All right. All right. All right. Interesting. Let's see a combination of these things. We're simplifying the top, then simplifying the bottom, just like we do in any real kind of fraction work. Example 2 says the square root of 27 divided by 100. Well, let's go ahead and split this guy up. Well, first, can we simplify 27 divided by 100? No. No, that's in simplest terms. I checked. Okay. So let's go ahead and make this the square root of 27 divided by the square root of 100. Ooh, 100. We know the square root of 100. So this is like dividing by 10, right? The square root of 100 is 10. 27 is not a perfect square, but what about 9 and 3? Hey, square root of 9. I'm going to skip a step in here. Square root of 9 times the square root of 3. We know that we could have written the square root of 9 times 3 and then broken it up. But notice how we're still using the product property in here. Okay. So now that we use the product property, we can say this is 3 times the square root of 3 divided by 10. And that is as simple as she gets. Once again, you're going to hit pause and try on your own number 3 as an example. Give it a shot, then come back. Check your work. Fantastic. Let's go ahead now that you've paused and given it a shot. Let's go ahead. Can I simplify 24 divided by 121 into a more simply termed fraction? The answer is no. I checked that one as well. Need to make sure we can do these. Square root of 24 divided by the square root of 121. It's like I picked these numbers for a reason. Hey, 121, that's a perfect square. This is like the square root of, well, I'm going to leave that out yet. I've got 121. Square root of 121 is 11. Ooh, what's my biggest perfect square in 24? Well, I've got, it's 25, obviously, no, 16, 9, 4. I could do 4. I could make this the square root of 4 times the square root of 6. We know the square root of 4. This becomes 2 times the square root of 6 divided by 11. All right. So those are our first 2 things, little skills that we're going to be working on. Okay. And we're going to work on throughout. What happens, let's say what happens if that denominator isn't a perfect square and I still end up with some kind of square root in there? Well, we don't want that. We don't want a square root in the denominator. We don't want a square root in the denominator. So what we're going to do is we're going to do something fancy. We're going to call this rationalizing the denominator. In other words, we're going to get rid of that denominator that has the square root. How, you ask? I think that's a great question. Let's go ahead and take a look. On the next page, we have rationalizing the denominator. It is mathematically nicer not to have square roots in that denominator. To take care of this, we multiply by 1 in a specific or fancy kind of way. Well, what do I mean by that? Let's look at that first example here. Square root of 121. I picked these numbers so well. All right, divided by 5. We can make this the square root of 121 divided by the square root of 5. Okay, we know that top, the square root of 121 is 11, but the square root of 5, you can't simplify that any further. But we don't like that in the denominator. We don't like that square root. So here's what we're going to do. We've got this square root of 5. Notice we've got a square root in the denominator. Here's what I'm going to do. I want to multiply by 1, but not just any version of 1. I'm going to multiply 1 as a fraction here. Well, here's something interesting. What is the square root of 5 times the square root of 5? Kind of write this on the side here. What is the square root of 5 times the square root of 5? Think of this as a couple different ways. You can think of this as the square root of 5 squared, and square roots and squares kind of cancel each other out, right? Simplify out to give me 5. If you don't see that right away, we could have also made this a square root of 25 using our product property, the square root of 5 times 5. And we know that the square root of 25 is 5. Okay. So here's what I'm going to do. I'm going to multiply both the top and bottom by the square root of 5. Is that legally, mathematical-wise? Yeah, because I'm just multiplying by 1. I can multiply anything by 1 and it doesn't change it. It doesn't change it. Might look a little different. So let's see what this ends up being. On the top, I have 11 times the square root of 5. That does not simplify. 11 times the square root of 5 divided by the square root of 5 times the square root of 5. We just said that's just 5. That's just 5. Now, these things are equal. 11 divided by the square root of 5 is the same as 11 root 5 divided by 5. One thing that you'll notice, you cannot simplify any further. You cannot simplify these two things. Do not do that, because the square root of 5 divided by 5 is not 1. The square root of 5 is not equal to 5. In fact, it's a little more than 2. So a little more than 2 divided by 5 is not 1. That does not simplify. Let's look at one more example here. One more example before you try one on your own. The square root of 2 divided by the square root of 27. Interesting, interesting. Well, I mean, I've already, split this up a little bit. Let's take that top. That does not change. Square root of 2 divided by, well, we've done 27 already, right? That's 9 times 3. Square root of 9 times the square root of 3. So 3 times the square root of 3. We've done this one already. Now I need to get rid of that square root of 3 in the denominator. I need to multiply both top and bottom by the square root of 3. On top, what do I get? I get the square root of 2 times the square root of 3. That's interesting. It looks a lot like what we did in that product property business. We'll come back to that in a second. On the bottom, I have 3 times the square root of 3 times the square root of 3. What does that become? What is the square root of 3 times the square root of 3? Square root of 3 squared, or the square root of 9, which we know. That becomes 3. So let's do the bottom and then the top. We've got 3 times 3 because that became 3. On the top, let's go back the other way. Before we were taking and breaking up things in the product property, let's bring it back together. Let's make this the square root of 2 times 3 in the top. Let's simplify the top. Square root of 6 divided by 9. That is our final spot for this one. Do not forget, that is not 6 divided by 9. You cannot simplify that. That is the square root of 6 divided by 9. You cannot simplify that any further. With that knowledge, go ahead and try the bottom. Go ahead and try the bottom, hit pause, and then come back and let's talk about that. All right, you've paused, hopefully. Let's go ahead and take a look here. That top doesn't change at all, right? Top doesn't change at all. It's just 2 for now. Let's look at the bottom, the square root of 24. Let's see, 9 doesn't work, but 4, hey, 4, we could make this the square root of 4 times the square root of 6. Okay, and we know the top is 2. What's the square root of 4? Yeah, 2 times the square root of 6. Can I simplify anything? Hey, I can, right? Before I do anything else, I can simplify. What is the square root of 2? I'm sorry, let me try that again. Back up. What is 2 divided by 2? 1. This would simplify to 1. I end up with 1 divided by 1 times the square root of 6, or just square root of 6. And now I can rationalize the denominator. Multiply both top and bottom by the square root of 6. I'm just multiplying by 1. Fancy version of 1. It's a fancy version of 1, but we can do that. This becomes the square root of 6 divided by 6. All right, so you've got some practice. You've got some practice that involves all 3 of these things. And the goal is rationalizing the denominator, but in that you'll have to do all 3 of these skills. Okay, not just rationalize. You'll have to do a little bit of quotient property and a little bit of product property in there as well. So with that said, take care of business, get it done. We'll talk to you later.